Good evening all. I'm Sohan Maity, a second year undergrad student of EC department from the IIITM Karnool, and I am presenting this final project of brain tumor detection using VGG16 model as a final project presentation of Samsung Innovation Campus under the guidance of Prasad sir. So first we will take a look into the objective of the project. The main purpose of this project was to build a CNN model that would classify if subject has a tumor or not based on their MRI.
Carry on.
What we have done is we have taken accuracy to look into how much the training model is satisfactory or not. So how to calculate the accuracy? We have taken various images from Kegel dataset and trained the model, and then when we test with several other data sets or several other images that we have taken from outside, the calculated accuracy should be number of correctly predicted images by total number of tested images into 100%. So according to my model, the accuracy was 88%, as the final test set was 82%, while training it was 88%. So when we look into the dataset description, I have taken binary representations as 0 to encode no tumor and 1 to encode tumor. So we can see in this image that there is a lump present in the brain. This is a brain MRI scan taken from top layer. So this is how a tumor looks in the metastasis. So firstly, we tried to create an environment to train the model. I used some libraries. So first I have used immutils. It provides convenient functions for image processing, particularly with OpenCV. And then several other libraries are used, as I have used Plotly to demonstrate figures. Then I have used TensorFlow as image augmentation. I have used VGG16 model because I have used some pre-trained data from that using CNN. Then there are models like I have used sequential for model building. I have used Adam as an optimizer. I have used early stopping as training control. Next, there are some mathematical computations done with NumPy. PQDM is used for displaying during loops, and I have used CV2 to process several images. Then I have used matplotlib to plot the graphs. I have used TensorFlow as, and then I have started with the Kegel dataset. Here you can see that we are uploading the Kegel dataset from the API key, and this function is used to unzip the dataset where it was uploaded. Then what we did is we segregated the dataset into several outputs where the dataset have the brain tumor or not. Then we have done a testing and training module where the images are separated, which has tumor and which has no tumor. So the no file describes that the image segregated into no tumor, and yes, it has the tumor. Then we are importing data into the context. So we have used X and Y to denote arrays, where X represents the images and Y represent their labels. We have used OS to read them. So first we uploaded the non-tumor images, and then we uploaded the tumor images from the dataset. So this is how the uploaded images look like. It has a mix of non-tumor and tumor images. According to me, this seems like a tumor image and that seems like a non-tumor image. So then we built the CNN model. So firstly we started with data augmentation, where you can see that we have inputted an image, then we are doing convolution. After that we are pooling, then we are again doing convolution. Then a fully connected neural network is there which gives the output. So firstly, we see that we input the image, then convolution of pooling layers is done, then flattening the layer is done, then fully connected layers are classified, and then output layer. Finally, we get the output of the image. This is how it looks like. Nextly, we are training the model. So we are training as X-train and Y-train, where X-train denotes ensuring that the CNN model is trained on one part of the dataset and evaluated on the other. X-train contains images, Y-train contains the labels. After processing steps, I have used a label encoder to convert that to number. Then then I have fit the label encoder on all unique labels. Then I transformed the labels, converted the labels to one hot encoding, and then converted to NumPy arrays. So now you can see that I have shaped the image datasets. So firstly, the X-train shape is 169, 224, 224/3. It is the shape of the image dataset. Next, it is the shape of the testing image dataset. The Y-train suggests that the labels are shaped properly. Then I started with the model building. So here, after running that, the model provided me data of a tumor and a no tumor image of the total data set. So we can see that wherever the lumps are present, the model is returning back tumor, and where I cannot see any lumps from naked eye, it is returning no tumor. These images don't have lumps, so they are returning no tumor, but here I can figurize that lumps, so it is returning tumor. So then I plotted the data into matplotlib to visualize the data. There were a total of some 104 plus 65, which is 169. So total of 169 images were present. So out of which no tumor came out to be 65 images and tumor came out to be 104 images. Now we are using Keras and VGG16 to train the model. What we have done is we have freezed the layers. We have freezed 4 layers basically, because we wanted to just use VGG16 and input my own layers, input my own 4 layers, and use a pre-trained VGG16 model also. So when I freezed, it shows false, 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 false on every 4 layers, because these 4 layers are freezed. Then I have trained the model just the top layer of the model is trained. You can see I have just used the ReLU function to train the model. So after training, this is the output where all the layers are pre-introduced. Only what I added was I added some layers at the bottom where dense 1, dense 2, dense 3 and global average pooling. These 5 layers were added by me. So they came. So this is how it looks like. So firstly, these are convolutional layers, then max pooling is done, and these layers are added by the user from top. So after that, I have tested the model using TensorFlow, and then I have given learning rate to be 0.01 and used the Adam optimizer, and then I have given epochs as 15. So there are 15 epochs, which firstly it showed some 50% accuracy, then its accuracy increased to 83%, then it decreased to 80%, then it increased to 84%, then 86, 86, 90 and so on. After that, we plotted the result at matplotlib, the training and final test set validation accuracy. First we are seeing whatever in red, it's the training set accuracy, it goes like this, but the final test set accuracy just follows it, but it takes some deviations. So it shows some error, but at the end it finally gets to what path it needs to take. After which, this is the code for testing a image from outside. Here brain tumor model.h5 is my model, and I want to import some other image from other than the Kaggle dataset and test whether my model is working or not. So I'll test with this image. I'll try and test with this image. This image has a tumor, it seems. So let's see if it shows some tumor in it. This is a predicted tumor in the image. So its prediction was correct only. So now I would like to go to the conclusion of the project. So whatever I told, the project successfully trained a deep learning model using BGG16, and the model tumor was detected finally. We have several improvements. We can improve the accuracy. More data augmentation can be done, and we can deploy the model by using Flask, Fast API, or Spring based on that. Thank you.